Welcome back, 7.2, part 4. We've got two more examples to work through. Sorry. The first one here, number 18, for f of xy equals negative 5x e to the y, we're going to find all four second-order partials. So again, we have to start with the first-order partials. Now this problem is interesting. We've got x and y in it, one term. It has an x and a y, so we get a lot of derivatives here. The x is just an x. It's a power kind of a thing. And then the y is up there in an exponent of it, e to the y. So we've got two different rules that are going on. We've got our power rule to pay attention to. Oops, n, x to the n minus 1, or we're just going to get a 1 out of that x. It's not a big deal. And then we also have to pay attention that when we take the e to the y derivative, we just write it down again. Okay, so here we go. Again, I'll work across the paper. So starting with f sub x, let's see if we can go right to it. When I look at this one single term, I'm taking the derivative of the whole thing. I'll write this out maybe one time because it's still new. There's my active piece. Everything else is multiplying that x. So that x turns into a 1. And my result would be negative 5 e to the y. So there's my first partial with respect to x. Let's move on with this same first partial. We'll go to a different order this time. So if I look at x again, there is no x in negative 5 e to the y. I'm taking the derivative of negative 5 e to the y when x is my active variable. So my f sub xx is equal to 0. That can happen because there was no x there. If I start with that same partial with respect to x, and I work with y this time, now something happens, because I'm taking the derivative of negative 5 e to the y. And let me put the e in red too, maybe, just to make that clear. And so when I take the derivative of e to the y, I just write it down again. So my f sub x y is equal to negative 5, tagging along, e to the y. All right, all the way back to the beginning to work with y first. F sub y would be, let's see, we've got negative 5 times an x, and then the active part would be the e to the y. Everything else is multiplying, so that negative 5 times x times e to the y, that's all multiplication. So the negative 5x does tag along, and then when we take the derivative of e to the y, we just get it back again. So there's our first partial with respect to y. It's negative 5x e to the y. So let's take the derivative of this with respect to x. So writing it out, if we need to, negative 5 times the x, which we're going to take the derivative of, that's going to turn into a 1. And e to the y, also all multiplying. So since it's all multiplying and that x again turns into a 1, we get f sub yx is equal to negative 5 times 1 times e to the y, or just negative 5 e to the y. And yay, good, we got our same second order partial derivatives. So that's nice. And then one last partial to calculate, starting with f sub y and doing y again. We've got negative 5x times that e to the y, which just keeps coming back over and over again. So f sub y, negative 5x tags along because it's multiplying, and we get the e to the y back again. So there's our four partials for that particular problem. All right, last example is a transition question, getting us ready for section 3, 7.3. We're going to be doing max and min stuff again, and we're going to be looking for critical values, which you might remember the derivative would have to be 0. So let's look at this question. Number 24, for the function f of xy equals 5x squared plus 3y squared minus x cubed minus y cubed, find the values of x and y so that both f sub x and f sub y are equal to 0. So we're going to take those first order partials, no second order, and set them equal to 0 and solve and see what happens. All right, here we go. F sub x. This one's not too bad. As I scan the function, the x's and the y's are separate. So I've got some x terms to consider, and I've got some y terms to consider as I do each of the different derivatives. So maybe I can just go right to my derivative. So f sub x, from the x terms, I get 10x, skip over 3y squared, and then get minus 3x squared. Skip the y cubed at the end. And then f sub y equals, let's see, skip over the 5x squared, we get a 6y, and then minus 3y squared are the only terms with the y's in them. So we're going to set each of these equal to 0, and in each case it looks like we can do some factoring, some common factoring. Common factor factoring. So for f sub x, there's no number common, but there is an x. So I can factor out the x and get 10 minus 3x left over. Okay. So that tells me either x is equal to 0 or, let's see, if 10 minus 3x is equal to 0, negative 3x is negative 10, so x would be positive 10/3. Now those are two x values. That used to be enough, but we're looking for x, y points, right? An answer here actually needs an x and a y. So let's keep going and looking at the y part. 6y minus 3y squared equals 0. Common factor here would be 3y. That leaves me a 2 minus a y equals 0. So that tells me 3y is 0, so that y would be 0, would be one possible y coordinate. And then 2 minus y equals 0, I get y equals 2 as my other y coordinate. So what we have to do is pair all these x's and y's up. We're going to get 4 solutions. Each x matched with each y. Going to get the point x is 0 matched with y equal to 0. We get x equals 0 matched with y equals 2. We get x equals 10/3 matched with y equals 0. And we get x equals 10/3 matched with y equals 2. All right, so that's all we're doing right now is looking for those solutions. In the next section, we're going to learn about how to figure out if we have a max or a min or something else entirely. So this wraps up section 7.2. It's a big one. Do practice these techniques of taking derivatives, and then we'll see you in the next section.